introduce Dr. Ronak Shah, our today's speaker. Dr. Ronak Shah has done doctorate in mechanical engineering, and his PhD topic was design, developing and experimental work in micro combustion chamber with hydrogen as a fuel. He has over 22 years of teaching experience. He has worked as a lecturer in government polytechnic also. At presently, he is working as an assistant professor at ADIT, that is a CVM University affiliated college, New Gandhinagar, and he is working here as since 2010. He has, to his credit, 12 national and international journal publications. He has presented 7 papers in different conferences and workshops. To his credit, there are 2 patents published, and he has guided more than 10 PhD students. He is really a hard-working person and has very methodical and scientific approach towards the work. In spite of this, he is very kind-hearted person and ready to help anyone at any time. I warmly welcome Dr. Ronak Shah and request you to kindly start your session.
Thank you, sir. Thank you very much to Atal AICT and BBIT for arranging and sponsoring this type of FDP, which is helpful to all faculty. Now the FDP is related to derived energy and conservation, energy conservation and energy management. So now today's topic is related to my topic. It is hydrogen as a green energy for energy fuel for automotive industry. 1 minute. So this is today's my presentation content: energy scenario and alternative fuel for future mobility, need of green fuel, biodiesel and bioethanol, hydrogen and its properties, hydrogen energy development in India, application of hydrogen, vehicle with hydrogen fuels, micro combustion chamber, and conclusions. Initially, we start with the energy scenario and its challenges. So first one is that is increasing the population. In Indian point of view, that is the population, it is increasing day by day. And due to that reasons, we know that is increasing the populations, energy demand is also increasing. When energy demand is increasing, another word is there, that is if any persons they have grown with the help of energy sectors, in behind of energy sectors, somewhere that we can say if appropriate utilizations and preserving of energies, that is the 2 main key of the growth of any societies. So that's why we can say that is increasing the populations. So that's we have required to sustainable growth for the energy it is required. Another things are there, that is a better mobility. We also use the car and plane for the purpose of a better mobility. Instead of we can use a bike or bicycle. That's why the increasing the demand of the energy due to the better mobility. Another things that we know, that is a limited fossil fuel source are available. So as per the today's production demand ratio, that is energy reserves is limited. And earlier session, number of speakers already said about these things, that is fossil fuel reserve is limited. So due to that reasons, we have also think about for the another alternative source. Another part is that is a volatility in international oil price. We already know that is oil price day to day increasing. So we also think about it that is the price is increasing. So we have also think about that what is alternative for that. And another things are there, that environmental concern point of view, that we can say that is air pollution. It is increasing day by day. Due to the one of the reasons are there, that is the transport sectors. And transport sectors, it is also through that is a petrol and diesels that is a main important role to for pollution increasing in our environment. So that's why that need of alternative energy source as per the today's conditions. Now, I'm talking about the world primary energy demand by the fuel. You can see here in this graph that's the primary energy demand in a metric ton of oil equivalent. So it is clear from this graph that energy demand, it is increasing day by day. You can see here that is a day by day it is increasing the energy demands. So energy demand here you can see this is a white color. It is indicated the renewable energy source. So renewable energy source demand as a fuel, it is increasing after that 2015. It means scenario is also changed. So we also change with also change our mindsets, and we have used instead of our conventional source, through that we can convert into the renewable energy source. It is also indicated here that this graph, it is the installation capacity of uh, electricity production in India in 2020. Now, till now that you can see that is a coal is a major role for production of electricity. So it means it is a 55.42% is there. Now here you can see in the renewable section, that is the green section, it is a renewable, it is 23.51%. It is also that we can say it is higher because of in 2015, you can see it in earlier slide in 2015, its a percentage is less than 10. So now government is also said about these things. You can, I think you heard the 15th August our speech of our prime minister. He also said about this thing, that is he also think about that is a national hydrogen missions with the aim of India to become new global hub and the export of green hydrogens. Not only will green hydrogen be to the basic of green growth through the green job, but it will be also set example for the world towards the clean energy trend. Another things he said that to achieve the self realizations in the energy productions with the mixing of electric mobility, gas based economy, and doping the ethanol in petrol to make the country is a hub of hydrogen productions. So now this is a part that I can say about, that is in a renewable energy source, that is a demand or installation capacity, the percentage increasing day by day. Through this graph is also indicated these things. Now this is also given, that is the installation capacity of renewable source, that 23% is there. So now 23% is also split in these four basic sources like a small hydropower, wind power, biopower and solar. So now you can see that is a 39.78% that is a percentage of installation capacity of a solar energy source in India, and the 43.3% it is a wind power based installation capacity to generate the electricity. This is also think about that what about in 2030. So it is increasing, it is a solar area that is increasing because of the government is also given some subsidy and some that is some scheme regarding that is increasing or motivate the people to use the solar energy for the production of the electricity. So simple example it is there, that is a rooftop solar PV panel. So this is one of the best example to generate the electricity for the home for the domestic purpose. So this is the 2030 base energy production graph. So this is also indicated that renewable source, it is main source compared with the conventional source for electricity generation in India after 2030. So this is also, you can show this graph, that is hydropower, it is the maximums, wind is the second, and third is the solar. Because of, you know, that India is the world's third largest consumer of electricity and world's third largest renewable energy production. So many things are there why we have think about that is the renewable source, renewable source. Because of that, main important things are there. That is, India is third largest consumer of electricity because of the population is also increasing. So day by day, and due to that reasons, the consumers of electricity is also increasing, demand is also increasing. So due to that reasons, we have also think about that is in alternative source. So here you can see that is in renewable energy source point of view, that is a 136 gigawatt capacity is installed in 2020. So now that's why we can say in now the coal it is replaced by the some renewable source like solar, nuclear gas. You can see in this 2020 in this graph, you can see in 2020 the blue color, that is a part of that is a coal. So role of the coal, it is a 54 percentage for generating the electricity in the case of in 2020. But is you can see in the 2030 what is the role of coal, that is 32.7%. It means it is a reduced. So when it is reduced, so another source, the percentage it is also increasing. You can see here that is a 10.2 percentage is the solar based installation capacity of the plant is there in 2020. It is increasing, that 34.3 percentage. So you can think about is that is a increasing the renewable source, or that you can say it is a replace the coal in our energy sectors. Now, this is the conventional power that we can say is the less beneficial because of the cost is higher. Second things are there, that is a availability is less, and third it is a pollution, that is emission. So these three things are there. That's why the conventional power it is the less beneficial compared with the renewable and green powers. So renewable and green, it is also it is a differentiate is here. There is a large hydropower, municipal solid waste, so that we can also generate the electricity is there. Now green power, it is a wind, solar, biomass, geothermal, biogas, and hydrogen. These are the most beneficial source out there. You can see in this graph that is India. It is a Middle East country that is become energy consumers. That you can see in this graph. Now I'm talking about these things. 1 minute. This is the crude petroleum products and import in India. So you can see in this graph, this one that is this color you can see is orange color. That is the production of our crude petroleum productions. Now you can see in this line, this line it is related to that is a percentage of import. You can see this is a magenta line, it is import, and this one it is a yellow line, it is a total demand. It means you can see that every year that is increasing the demand. When the demand it is increasing, or increasing also the import percentage is also increasing, and that's why it is said about these things that is India economy is increasing. The growth is about 6.4% during the 2006 2030s, which is the fastest growth rate for any economy. Therefore the import it is dependence expected to grow up to the 87% by 2020 and 91% by 2030 as per the IEA projections. So you can think about it, that is increasing the rate of increasing the import rates in petroleum products. Who is exporter? That is a country for the Indian point of view, because of India is the third largest country. It is use the petroleum product, and India is importing the crude oil from various countries. But the main thing is that main country, that is Saudi Arabia, Russia, Iraq, Iran, and India is 82.8% import dependency from the for crude oil and 45.3% for natural gas LPG nowadays. So you can think about this through this graph and value of in rupees. So you can think about that is what is dependency in our crude oil. So which sectors it is important to consume the energy in our Indian point of view. Okay, in the world, here the world final energy consumption by the sector wise it is given. So energy consumption in that is a metric ton of oil equivalent is here. So it is evidence that energy consumption, you can see it is in magenta color, it is a transport. So we have discussed now in the transport sectors. So in the transport sectors, you can see that is increasing the growth. That increasing growth, it means that is the energy consumption rate. It is increasing. So in energy consumption rate is increasing. So in 2015 and 2030, it is also increasing. So this is said that is a transportation sectors will grow rapidly, and that's why the energy consumption rate is increasing. Yeah, it is impossible when the transportation sector will not grow, and then after the consumption rate is increasing, but it is increasing with the increasing the transportation sectors is also grow. So that's why the final energy consumptions it is higher in the case of the transport sectors. Now in transport sectors that we can use the various types of fuel. You can see that it's a diesel, gasoline, natural gas, aviation fuel, electricity and other fuels. Out of that we can see now more than 80 percentage that we can use the diesel and gasoline. Gasoline means petrol that we can use as energy consumption by the fuel in India in our transportation sectors. So it means what? That is the gasoline in diesels, it is also produced that carbon dioxide, carbon monoxide and NOx. And due to that reasons that is the emissions level it is increasing. So this is also the one thing that is the consumption it is higher by the diesel and gasoline, and another things are that is also create a problem in environment. Now how it is, how can we say it? Because of this one or two example that I have given, the which type of people are use the people are choose the car in I think in 2019. So they have choose the petrol as a product is the first number they have chosen is 57.3% people are using or choosing the new car as with the fuel as a petrol, and 29.5% people are using that is diesel as a fuel in a new in a 2019. But only 13.2% people they have used another alternative source. But so you can see that that's why the consumption rates of crude oil, that is petroleum product, is increasing, and simultaneously it is emission level it is also increasing. That also you can say in similar way in 2020 that percentage is also increasing the petrol and diesels. You can see here now it is one thing it is added that part is electrical charge battery, electrical chargeable vehicle is a 10.5%. It is good for us, and alternative fuel through it is generated is 2.1 percentage. So this thing it is said about thing that people are also start to think for alternative source of fuel instead of petrol and diesels. Because of one another things are that why people are thinking about that this price, you can see there's a petrol price in Bombay, it is increasing. You can say that it's increasing in 96 and 100 rupees till in 2021. So that it is also the one of the reasons is behind it people are think about the another alternative source in our transportation sectors. Sector-wise, that we can assessment of the carbon footprint that is across the major cities in India. So it's the maximum in the road transportations, and road transportations. You know that the maximum vehicle is run with the help of petrol and diesels. So due to that reasons, this it is increasing. That is a carbon footprint across the in our environmentals in our environment. Another things that is given, another example is they given that is transportation sectors estimated the CO2 emission growth during the 2015 to 30 compared with the another country, the India, the largest because of one thing, it is a population is there, second things are there, there is a V2 three-wheelers that is registered to three-wheelers, it is also number is also higher than because of the population it is also higher. So now I'm talking about the share of greenhouse gas emissions by mode of transportation. So you can see that is a 71.7 percentage the share of greenhouse gas emissions through the road transportation mode. So these all the things behind it that we have to think. Now another part that I'm saying about the vehicle ownership in India has been rising steadily. So now in x-axis that is the left axis, it is given the million of 2 and 4 wheeler vehicles, and in right side that is a percentage that is a penetration of 2 and 4 wheeler vehicles per 1,000 people. That we can also say it is motorization index is there. So now you can see that is in 2012 and 14, you can see this is near about the 180 or 170 million of 2 and 4 vehicles. So it is increasing. Now it is increasing more than 250 million of 2 and 4 wheelers vehicles are registered vehicles are available in India, and it is increasing. Daily it is increasing, not it is reducing. Now I'm talking about that is per person, per 1,000 persons, how many vehicles are registered. So you can see this line, it is rapidly increasing. So there is 140. Now it is more than 200. I think you heard the Dr. Chaniwala. He also said about that is uh, that is two-wheeler vehicle number of two-wheeler per person. That ratio is also you can see. We also said about this thing that is more than 200 vehicle per 1,000 people are in our India. So in the case that is two-wheeler and four-wheeler is also there, but which type of two and four-wheelers? That is also important things are there. So two and three-wheelers that you can say in this color, it is a maximum numbers. So maximum number is there in left axis, that is annual NOx emissions, that is 1,000 metric tons, and this is the vehicle stock in million of vehicles. So you can see that is two and three wheeler that we can use the maximum number of is there. It is increasing the also as per the year to year. So it is more than that is 150 plus vehicle stocks available in 2015. Now that I am saying it is more than 200 plus the vehicle stock in million vehicles are available. Two and three wheelers, heavy duty vehicles are also there. Now another, there is passenger vehicles. You can see this in passenger vehicles is also increasing the year by year, and it is also the role in increasing the pollutions. Okay. Now I'm talking about just two lines, that is a without 2003 auto fuel policy and a with 2000 auto fuel policy. So this national auto fuel policy, it is in 2003 is a it is a mandated in the 11 city for the new four-wheeler cars with the Bharat Stage 3 emission norms for conventional air pollutants and standard by the 2010. So that's why what happened that try to reduction of the emission levels and air pollutants. So you can see here that is NOx emissions in the case of with 2003 auto fuel policy, it is decreasing compared with without 2003 auto fuel policy vehicles. So that is also important things as government is also try to this type of policy is mandated for the some vehicles, and that's the reasons are there that is the annual NOx emission level is also reducing. Now the two-wheeler, it is dominated power transportation. Already in earlier slide is also we can see that's a two-wheeler. It is more in our transportation sectors, and it is also increasing the demand. And due to that reason, it is increasing the demand of the fuel. This I'm talking about there is an explosive motorization's growth across the Indian point of view. I'm talking about in 2005. You can see in 2005 that is the total number of vehicles in million. It is near about the 50 is there, and that is a we can say it is a motorization index is there that is near about it is also 50. But when it is increasing in 2015, and you can see here in 2025 it is near about the 250 million vehicles are available. And what about the motorization index? That's near about that is a 2. So motorization index means vehicle per 1,000 people. So that index that is near about 200 is there. So and here that we can say that is in 2015 that is the total number of vehicle is more than 250 millions. So this is also the one of the reasons that is increasing the mobility, and mobility increasing the fuel consumptions. So due to that reasons, the government is also think about it. As per the Paris agreement, that is, uh, it is taken as a benchmark, and India, in Indian power sector, is fully decarbonizations. That we can say emission reductions by 2050, that is a zero. So high quality and safe non-motorized and mass transit public transport infrastructures and service provide a wide range of alternatives to private motorized vehicles. A previous study on the Indian road transport sector showed that such a transport mode are viable options for decarbonization road transport, reaching up to the 90% by 2050. So he said about these things. Now you can see in this graph that is a percentage, that is a passenger and freight transportation emissions in metric ton CO2 for the year. That is, you can see it is near about 1170 metric ton. So now that 117 metric ton of CO2 per year it is produced due to the passenger and freight transportations. So how can we try to reduce the emission to 117220? With help of some roadmap is there, that we can say that is innovative urban planning. Through that we can try to reduce the CO2. Then another that is a model shifting and improve the efficiency of the model. Through that we can try to reduce the efficiency. Another that is electrification. It means that is e-vehicle that we can use. Through that is a huge amount of emission level that we try to reduce, and another that is alternative fuel. Through that we can also reduce the percentage of CO2 emissions. So this is given the annual emission from the transport sectors until 2050, and there is emission reduction by the 2050. This is a roadmap is given by the Indian government. In based on that, it started so innovative urban plannings. So innovative urban plannings. So he that is rupees 7 lakh crore investments made for the highway sector in next 5 years. They also use the plastic waste being encouraged in construction of national highways. So sustainable urban planning, and another word that is a transit oriented development, that is a TOD, through the region and urban development policies are there. Through they have tried to increasing the logistics and travel demand management, and uh, try to reduce the environmental pollutions. This type of urban plannings, it is also helpful to reduction of traffic. We know that in Ahmedabad the traffic it is more so congested is there. So reduce the traffic with the help of sustainable urban planning. It is also reduce the traveling time. It is lower traffic, and due to that reasons the injuries and deaths, noise and air pollution is also reduced, and improve the mobility and accessibility. So this is one of the way to we have tried to reduce the environmental pollutions, and also to save the conventional fuel. Now another things are there, that is a avoid, shift and improve. That is the framework is there. So this framework can help to guide the develop the planning around the minimizing the growth in the need to transport. So to avoid, it means the reduce the need from motorization travels. So transported demand management. So you can manage, that is a transportation sectors, that is vehicle that you can manage. Then another part is there, that is the shift. It means uh, it is a low carbon and efficient transport mode and support it. So how can, that is a railway that you can use, public transport that you can use, walking and cycling instead of a car and bike, and share mobility, it means pool car instead of individual car that you can use. Now, the third things are there, that is improve the energy efficiency of transportation mode. So new vehicle adhere to higher efficiency standards. So you can use the fuel economy, that is one of the part is there. Second, that is the electrical mobility. So electric vehicle that you can use and try to reduce the conventional fuels, and energy efficiency is also improved. Third things is the renewable energy. So use these things, that is avoid, save and improve. This framework, it is help to us to support the low carbon mobility. Another part, government is also think about, that is a use or implement, that is a Bharat Stage 6 norms with the take effect on India from 1 April 2050. So it is the most advanced emission standards compared with the BS4. In BS4, what happened? That is the sulfur content in the fuel were brought down by 100 ppm to 300 ppm in petrol and diesel respectively. But in case of here, in when we have used the BS4, so it is reduced the pollutions with the help of here, that's an NOx emissions will be brought down by 68% in diesel and 25% in petrol cars. And another important things are that the new norms make the onboard diagnosis. It is mandatory for all vehicles, and it is helpful to in onboard diagnosis. So you can find out your problem through the code stored in the computers. And for two-wheeler, that is manufacturers will introduce the fuel injection systems in India instead of that carburetor in our petrol engine. This is the petrol emission norms. It is given in the BS3, BS4, and Euro 6. It is given. I'm talking about that is here in our two-wheeler, in a petrol engine, they have changed the instead of carburetor, and instead of that they can use fuel injection systems. So in fuel injections, that we already know, everyone know about that what is the function of the carburetor. It is control the ratio of the air fuel mixture is entering in the engine is known as a carburetor, that we already know. Fuel injector is also done same work, but in the case of quantity of fuel injection timing control, it is digital through the electronic device. That name is, that is the electronic control unit, and it is connected with the sensor and to measure the engine temperature, oxygen level, and air intake and total butterfly positions are. And through this sensor, the electronic control unit get the measure and determine the quantity of fuel to spray. And that's why the modern motorcycle engine capability and efficiency is increasing. Its the reason is behind it, that is a precise quantity of fuel injections and mixing of air fuel ensure the maximum possible fuel efficiency and power productions are there. So nowadays it is adopted in motorcycle fuel injection systems, and another things are there. It is also helpful when the no code that start issue in the fuel injected engine, so no need for manual choking is also there. So these are the advantage behind it. Some changes and modification in model that I am saying is the second case. Now this is also, that is future emission regulations are there. That is another thing. There is a global warming are there. So I'm talking about these things that already we learn about all the things. So energy is there, must be technology advancement, that already it is explained by the Chaniwala sir. Results, that is a fast depreciation of fuel reserves. Pollutions is associated with events. The challenge is also there. So that's why, what can we do? We have to search for the sustainable green energy solution for a better tomorrow. How it is possible? This means that we must be search for feasible technology pathway towards the sustainable green energy solutions. Further, this solution must be adaptable to existing technology and not imaginary. So that's why we have used the renewable energy, green energy. In green energy, we can use a biofuel and hydrogen. That government is also some sustainable for some different goals. I think 17 goals for sustainable developments. Out of that, that we can use, that is only the two goals, that is climate action and the life of land. Through that, we can develop our sustainable source as a green fuel. So green energy, what is the meaning of that? Like first thing, what is the meaning of the green energy? There is energy that is generated through the natural resources like sunlight, wind, and water. And according to Environmental Protection Agency, the green energy provides the highest environmental benefit, including the power production by solar, wind, geothermal, biogas, low-impact hydroelectric, and certain eligible biomass sources. These are the source for the green energy. You can see in this figure also that solar energy is there, that is wind, that is hydroelectric, wave power, tidal power, geothermal, biofuel some, that is the electrical vehicle is there, hydrogen is there, and this is a fuel cell. So these are the basic source for the future of green fuel. So green fuel that we can say it is a biofuel, is a type of fuel that is distilled from plants and animal materials. So believed by some to be more environmentally friendly than the widely used the fossil fuel that power most of the world. We can also say that so what is the meaning of green energy, clean energy, and renewable energy? That is also there's some different, some minor difference between these three things. In green energy means which has come from the natural source like the sun, wind. What about the clean energy? This type of energy do not release the pollutant gases in the air. That we can say it is a clean energy. What about the renewable energy? That is come from the source that are constantly being replenished, such as hydropower, wind energy, or solar energy. Here is one example that I have given, that is some form of biomass in a renewable energy source, but not a green or clean energy because of it is release some pollutant gases. So need of green energy to reduce the carbon emissions, preventing the further environmental harm. So what is the impact of green fuel in the world? Three things are there. That is gives us the green society, keep up the free from CO2, and give us the fresh environment. So how can it is possible? So possible with the help of how we produce the energy, which type of energy that we can produce. So increase the use of renewable source of energy, which is reduce the emission level. How we use the energy, ensure the less energy is used efficiently for maximum output, and this word is that we can say that is energy conservation. So energy conserve, energy manage, and how we discharge the energy, that is reduce the greenhouse gas emissions and air pollutant with the management. So this our today's FDP topic is related to that this type of sustainable energy that is conserve and manage. Green fuel, that also we know that is a biofuel and it is produced from the biomass sources with the help of biological and thermochemical process are there. And three ways that we can prepare or produce the biofuel, that is biodiesel, bioethanol, and third things are there that we can say it is biomethanol. So biomethanol, it is a new topic, but we know that in IIT Kanpur, they also start to work on the biomethanol. So biodiesel is initially made from the vegetable oil. It is made by that is Rudolf Diesel in 1980, and bioethanol is made from the sugar, algae, wheat, and sugar beet. And biomethane is produced from the waste organic material, agriculture waste, and domestic waste. So biodiesel is a form of diesel fuel that is also we can say it is classified as biofuels as per the generation point of view. So first generation biofuel that we can say it is including the sugar, starch, and vegetable oil. Second generations that we can add, that is a wood and waste plastic is there. Now the third, that is algae. Through that we can extract the biofuel. So how it is possible? That is a same thing. It is given by ethanol, by oil, or the pure petroleum oil is there. There is a kerosene substitute is there, and fuel oil. It is a substitute. Here in biodiesel, the diesel fuel is substitutes are there. So I am talking about how it is prepared. That is, simple things are there. The various feedstocks are there. Through that, it is produced the green fuel. How it is possible? That is a treatment, and that is a conversion technology that already we know. That is gasifies also there. Gasification process, pyrolysis process are there. So product upgradation and development through that, and then after it is converted into the hydrogen, butane, ethanol, biofuels, and that we can say it is a green fuel. So this is a life cycle of fuel and in the distribution to the end user, how it is possible. That is feedstock. Now feedstock, it is transportation through the truck into the refineries there. Now in refineries, it is the conversion process are there. After the conversion, there is a distribution part is there, and after the distribution, it is used to the car. So this is the end users. This is the biofuel life cycle. Now I'm talking, these are the various feedstocks, that is again soybean, corn, sugarcane, so algae, jatropha. These are various biofuel feedstock people are using now, that agriculture waste, animal fat, and vegetable waste, everything that is a palm oil. These are the feedstocks are there. You can see in this first generation, that is in a first generation, you can also produce that is a biowaste with the help of the food waste, animal manure is there, there is a crop is there. You can also go, that is a biodiesels, that is also the part of that is a first generation, and it is utilized in a tractor or any other place are there. Now the secondary generations, that is a biomethanol, is also we can produce with the help of municipal waste. Then the manure is there, that is another, that is we can use the biohydrogens is also produced. Now the synthetic biofuel is also produced with the help of algae. It is a microalgae, through the directly you can generate the hydrogen fuels, or we can say it is a biofuel that also you can generate with the help of algae. Now I'm talking about the biodiesels. We know that everyone know about the biodiesels because of number of people are doing the research work in this biodiesels. So just I'm saying only one things are that is the biodiesels. It is used with the help of various feedstocks that we can use, and prepare it with the help of various thermochemical processes are there. And main use of biodiesel can reduce diesel engines overall emissions rate. That is our requirement. And this thing, it is happening in the case of when we have used the biodiesels. So produce the less air pollutant than the petroleum product like the diesels. And that's why we have used. But biodiesel is produced, that already we know, that is vegetable oil and animal fat, etc. is there. That is a, but the problem is that is a biodiesel is currently about 1.5 times more expensive than the petroleum diesel fuels. So part of this cost is because the most common source of oil is the soybean, which we have used, the 20% is oil. So biodiesel is not distributed as widely as traditional petroleum diesels nowadays. That biodiesel also, that's a non-toxic is there, biodegradable compared to the petroleum diesel fuels, which is refined from the crude oil. So biodiesel combustion process is fewer the air pollution. That's why I'm saying that people are using these things. So biodiesel is reduce the greenhouse gases emissions also. So this is one of the alternative source for the in our transportation sector is the biodiesels. So this is a total cycle to biodiesel. It is work from the oil crops. The seed, it is extract, that extract the seed, it is converted into the vegetable oil, it is refined, and then after with mixing with alcohol, it is the process is that is a process that is after this process we can convert it into the glycerin, and there is a biodiesel is also there. Then after it is entered into the vehicle that we can use, and it is generate the energy and CO2. So this is the biodiesel cycle. And that I'm saying that is what is the production cycle are here that already you know. Some results are that I put it here, that is a Jatropha biodiesels. Jatropha is used as the bio mass and the diesels blending. And here you can see the blue is a diesel and another two colors is a blending 20 and 25 percentage. One author is he published this paper. Number of authors, I think more than 3,000 papers. It is related to the biomass and bio diesels are there. You can see here in the NOx percentage, it is higher in the case of after blending also. Sometimes it is normal that we can say it is reduction of NOx, reduction of CO2, reduction of CO is there. That is also true. But in some cases, this thing it is also happening. So we can also think about this. In every case, you can see that is a yes, CO is carbon dioxide is reduced, CO2 is it is increasing, but NOx is also increasing. So these are the different results are there. So and due to that reasons. Biodiesels that we can use, I think number of companies like Audi, BMW, they are also made a diesel car model, and now that they can use biodiesel blends. Okay, so now another things that I can say, that is a third generation of biofuel, that is algae is there. That is the main thing is that it is extractions when it's contact with the solar, and then after it is oil extraction are there. There is a here that is a protein residues and biodiesel production is there, and is a byproduct is the glycerin, and that biofuel it is refined and it is until the is used for the car. So this is also the one existing systems are available in the market. It is also helpful, but what about the productions? This is how to make the biodiesel using the algae is extract, that is a microalgae, that is harvested and then it's extracting. That's the two ways there with the using the solvent and press, and then after we can get that is a biodiesel. This is a bioethanol. You can also say this is a bioethanol. It is also important. Important fuel is there because of is bioethanol fuel mainly produced from the sugar fermentation process. Although it can be also manufacturing by the chemical process by reacting ethanol with the steam. So ethanol is a clear colorless liquid fuel is there. Now government is also think about, you can know that there is a government is also think about that is only now the 5% is there. Now it is increasing the 10% ethanol and 90% petrol vehicle in any requirement for modification to run E10 and vehicle that is without any affection. Now it is run in a market. So same way you know that about in the case of government is also think about that is a 20% ethanol it is mixed with the petrol, and why that we can choose because of gasoline it is increase the octane level, improve the quality of emissions. So this is the reasons is behind it that bioethanol is one of the best solution or alternative of conventional fuels. So bioethanol is also used because of less toxic. Second thing that we can say, it is depends on the potential of that. There's a bioethanol productions, various feedstocks that we also available. And through this bioethanol and biomethanol and biodiesel, we can also think about it to, it is also put impact on the socio-economic. Because of bioethanol productions open the new market opportunities for the agriculture products, and thus a new income option for the farmer. In the future, agriculture will not only play a role for the food production, but also that is energy provisions are. This is how can we get it the bioethanol. This process are there, that is fermentation process required 3 days to complete, and it's carried out temperature of between 250 to 300 degrees Celsius. This green car, that is the first stage 5 is there, and this is run at Nagpur in Maharashtra. Some another results are there that is related to the diesel with ethanols. So that results is also indicated that percentage of NOx is also reduced in the case of we can use the percentage of ethanol. You can see that in ethanol percentage of 20 with the diesel, that also it is reduced. But when we can use some additives, so then also it is reduced the NOx level. So people are trying to research in this particular area to reduce the emissions level with the additive that you can use with the diesel and ethanols. That is another graph. It is related to the percentage of CO with diesel and diesel ethanol. You can see here that that is diesel, ethanol, and additives that is also reduce the percentage of carbon monoxide and carbon dioxide is also so very so here not only the SI engine, but here in a diesel engine also that we can use that is a bioethanol product. Now another comparisons you can see here, that is a gasoline, butanol and ethanol. So in equivalence ratio is 1. So you can think about that. What about the NOx generation? That is it is very low compared with butanol and gasoline. So that's why we can say that is one of the alternative source is bioethanol. Now, what is the issue with the green fuel productions and uses? This is the most important things are there. We know about that biofuels, biodiesels, and bioethanol, and then after our Prime Minister said that is we are going for the mission of hydrogen mission. That is the reasons are behind it, that some dispute or issue is regarding the food versus fuel debates, the carbon emission level, sustainable green fuel productions, deforestation is also there, soil erosion, impact on water resources because of the in farm that is also it is required the water resources, human rights issue, the poverty reduction potentials are there, and energy balance and the efficiency. So these are the reasons, these are the issues, and due to that reasons we have not prepared for the accepting the fuel like the biofuel, biodiesel and biomethane. We have think over it because of these are the issues there. So that's why the government is also given the third options, that is electric vehicles. So electrical vehicles is called the electric is vehicle that use one or more electric motors or the traction motor for the propulsions. So EV is also called the battery electric vehicles. Here battery that is charged by the plugging the vehicle in the charging equipments. So you see here that is run only the 150 to 30 mile, and then after you can again we are going to charge. So in electrical vehicles use the lithium ion batteries, and the lithium ion batteries have higher energy density, longer lifespans and higher power density. And due to that reasons people are using the lithium ion batteries compared to with another conventional batteries in electrical vehicle. And another factor that is safety, that is durability, thermal breakdown and cost in the case of lithium ion battery is better than other alternatives. So lithium ion batteries should be used within safe temperature and voltage range in order to operate safety and efficiencies there. Now, how many registered the EV two-wheeler sales in India? In January 2020, it is 15, that is 1,000 plus that you can see. So this is a graph. It is indicated that people are start to change their mindset and use the two-wheeler, that is with electric vehicles. Same way for the electrical three-wheelers. In this car, there is a number of vehicle it is registered. In this, you can show that is in green color. It is indicated that is a cargo. It means that is a freight cargo is there. So it means loading vehicles, three-wheelers, and this is a passenger vehicle. Three-wheelers are here. So these things are here in a sales trends that is also increasing. Same way in two-wheelers. So people are think about it for the registered or purchase new electrical vehicle compared with the conventional fuel vehicles. This is a rise of electrical cars. That is a projection of annual sales. You can see that is in year, and it is a cumulative sales. You can see in 2040, electrical vehicle would account 35% of new vehicle sales. So it means percentage of electrical vehicle registered is also increasing day by day. Because of government India is also prepared the roadmap for this electrical vehicle, and one another things are there, that is the price, that we can try to reduce the price of lithium ion battery, that is energy storage. So that we try to reduce. In 2017, that price you can see here in the dollar, but now you can convert it. It is start to you can see this graph. It start to decline. It means it's a reduction of the price. So price it is expected to decline up to 12 percentage. So due to that reasons, people are think about it to change your vehicles instead of conventional fuel to the electrical vehicles. Now government is also think about that is India is also beat USA, that is a US, in electric vehicle sales in 2040. You can see here the 2040, that is 60 percentage. It is in million of vehicle that we are going to purchase the Indian people compared with 57 percentage in USA. So this is a projected graph. It may be possible. So it is helpful to us. But why people are now think about it, why we are not going with the electrical vehicles? So that is the reason is behind it. That's the electricity storage is still expensive. Battery charging is time consuming. Primary sources depreciation of same elements of the lithium ion battery that we can use, because of lithium ion battery charged with the help of, that's the primary resources, the conventional resources are there. So range, that is also problem, 157 170 kilometers, and then after what, there is battery degradation cost. Sufficient public charging infrastructure is still lacking and causes the indirect pollutions are also there. Lack the power to isolate and claim the quickly. Heavy duty to overloaded batteries. So these are the disadvantage, and people are think over before they are purchasing the electrical vehicle. Now, what about another alternatives then? You can see in this graph that is only one thing, that is 14% hydrogens, and this 14% that is a hybrid plug vehicle that we can use for the as another alternative source. So now we have think about it, that is a vehicle on the road, everything that we have learned. So now we can go for another source, that is a fuel roadmap for our futures. So this is the past that already we know, that is a conventional fuel that we can try to improve the quality, and based on that, one thing it is done, that is fuel injector that we can use in our two-wheeler vehicles. Now people are using the CNG and synthetic fuels, and first generation biomass and second generation biomass that people are using in electrical vehicles, and then again people are using that hydrogen. Why hydrogen? Because of that is a zero emissions, efficient energy carrier. That is one of the major things are it is behind it. So why people are using the hydrogen? Okay. Now, second, you can see that is easily transported in large volume. Infinite supply is there. Can be produced with no carbon footprint from the multiple sources are there. And then after the high energy density, reduce the clear power and the heat at the point of the uses, can be stored in a large quantities and for long periods, and that's why we have used the hydrogen as a fuel. These are the source that is produce the hydrogens. that is through the natural gas, biomass, solar, nuclear, wind, fossil fuel, geothermal, electricity. These are the source of energy through that we can generate the that is the hydrogen or produce the hydrogens. The production pathway that also we know that is a various methodologies there: electrolysis, biological, direct solar water splitting, and steam methane reforming. These are the four basic methods now people are doing work in this area to production of the hydrogen. This is energy carrier. Hydrogen is the simplest and most abundant element. It is energy carrier, not an energy source, and can be delivered or stored energy. It has a very high energy content and can be used in fuel cell to generate the electricity or power. Nowadays, that is a 10 million metric tons of hydrogen are produced per year. Various where that you can use, that is a stationary fuel cell, chemical, energy storage, petroleum refineries there, fuel cell vehicles are there that can use the hydrogen. So here it is also given same way that power generation, synthetic fuel, hydrogen vehicles are there, heating purpose, metal refining, and that is ammonia and fertilizers. At that particular place that we can use the hydrogens and hydrogen technology. Hydrogen fuel is zero emission fuel when burned with oxygen. It is also used in the propulsion of space, aircraft, and might the potentiality by the mass production and commercialized by the passenger vehicle and aircraft. These are the comparisons are there that are not going much more time in the case. But people are saying that hydrogen water will be called for the future. That is important things are there because of decarbonization of fuel. Decarbonization, it means there is no carbon contents are there. So that's why we can say it is a decarbonization of fuels. This diverse energy sources and diverse applications are there where that we can use. That is a simple number of times that I can say it is a fuel cell, engines, turbine, energy storage, that fuel that we can use in chemical point of view, petroleum recovery, the refinery that we can use, methanol production, electronics item, ammonia production, metal production, food processing, cosmetics. At that particular place that we can use the hydrogen, clean energy. And from where that we can get it, that's natural gases, renewable energy, nuclear, and coal. This thing it is also given that is from where that is power that we can use, and hydrogen we are produced and where we utilize. These are the properties of particular fuels. Now, first thing is a low rating value, it is higher, and it is the best way. It is a kilojoule per kg, so it means that calorific is very high, and it is best for fuel compared with another fuel. Now I'm talking about the flammability range. So flammability range, it is low, it is higher. You can see it is a 4 to 75. It means what? So in our IC engine, so wide range of fuel air mixtures. So fuel air mixture is high, it means the hydrogen run in a lean mixture also. So lean mixture means what? That is the fuel is less than that is stoichiometric, or that we can say is a chemically it is ideal amount needed for the combustion with the given amount of air. And due to that reasons, what happened is a hydrogen engines start easily compared with the gasoline or CNG engines. Another thing is that is the final combustion temperature. Because of that, we can use in a lean mixture in our hydrogens, and that's why the final combustion temperature is also lower. And due to that reasons, that is reduce the pollutant gases like NOx emitted that we can reduce. Meaning this thing is that. Now I'm talking about that octane number, it is near to the CNG, that is 130. Now another the molecular weight is low, that we already know, that is the molecular weight of hydrogen is low compared with the gasolines. Now another thing, that is the minimum ignition energy. So ignition energy, it is low. So amount of energy, that is what is there, that is amount of energy that's needed to ignite the hydrogen is about 1 order of magnitude which is less than that is required for the gasolines. So this is enable the hydrogen engine to ignite the less mixture and ensure the prompt ignitions are. Another thing, sir, you can say that is a diffusivity in air, that is 0.63. It is higher than that is a gasoline. So there is ability to disperse the hydrogen in air is greater than there is a gasoline. And that's why somewhere it is the hydrogen leakages are there. So hydrogen disperses rapidly and unsafe conditions can either be avoided or minimized compared with the another fuel. Now you can also see that is a high flame speed is there. Flame speed it is high. You can see here there is a flame speed is high. That is flame speed is nearly in order to magnitude is higher. It is a faster than that is a gasoline that we know. This means that is hydrogen engine can more closely approach the thermodynamically ideal engine cycles. So at lean mixture, the flame velocity decreases significantly, and it is helpful. So hydrogen is used in in a lean mixtures. So this is one of the things that are there. Now another thing that I'm saying is a low density. This is one of the disadvantage of this hydrogen fuel. Its power output is reduced and more volume is required to store the hydrogens. So this is the one of the disadvantage of this fuel. It is colorless, odorless, tasteless, and non-toxic fuel. Okay. Now it's a wide range of flammability that we already know. Then the lean burning, it is results in complete combustions and battle fuel economy that we can get it. Low ignition energies that is enable the hydrogen engine to ignite the lean mixtures and ensure the prompt ignitions that we require. Now this is some graph. It is related to the hydrogens. Now small quenching distance. That is small quenching distance. It means smaller than that is a gasoline. That is a difficult to quench a hydrogen flame than gasoline flame. So one things are there, that is a backfire effect. So backfire effect is increasing. This is one of the also the disadvantage of the hydrogen fuel that we can use. So high auto ignition temperature that we know that is near about the 570°C is there. So the larger compression ratio is resulting in higher thermal efficiency is also there. Okay, so we can get that is a higher efficiency also that we can achieve. High diffusivity that already we have discussed with these things. So hydrogens now used in internal combustion engine. So in internal combustion engine, that is two things, three: diesel engine, spark ignition engine, and natural gas with the hydrogen mixer. That is a CNG plus hydrogens. So you know that in the case of hydrogen cannot be used in solo fuel in the CNG engine because of the compression temperature is not enough to ignite the combustion due to the high self-ignition temperatures. This is the reasons are there. Now I'm talking about that is hydrogens with the diesel engines are there. So increase the hydrocarbon ratio, that is the fuel ratio is that hydrogen and carbon contains the ratio of the fuel. So injecting the small amount of hydrogen to a diesel engine, better combustible mixtures due to the high diffusivity of hydrogens. Reduce the NOx emissions are there, increase the thermal efficiency, and reduction in fuel consumptions are there. One another things are there, that is NOx reductions. Because of in hydrogen, there is no carbon content is there. But when high temperature and when rich mixture is there, so NOx productions are possible. And that's why we try to reduce the NOx reductions and increase the thermal efficiency and reduce the fuel consumptions with the help of this EGR. EGR, that is an exhaust gas recircular. It is very effective in reducing the NOx emission due to the diluting effect of the oxygen concentrations of the intake. Here that is a intake a charge is reduced and volumetric efficiency reductions with increasing that EGR rates are that is near about 15% is compared with the hydrogen dual fuel operations without EGR are recorded. Okay, so that's why the EGR it is also helpful to us for reduction of so this is a SI engines. Here you can see that is the hydrogen cylinders This is a flame trap, and there is a flame arrestor. Through that is a hydrogen. It is entering the manifold, and intact air is also mixed with it, and it is entering into the single-cylinder engine is there. So here there is a fuel directly injected in the internal combustion engine. This spark ignited engine is that is the most unique. Is directly that we can use without less modifications, and we can also use the ultra lean combustion process, and it is produced at low flame temperature and lead direct to lower heat transfer to the wall, and higher engine efficiency and lower exhaust of NOx emissions are there. And due to that reasons, after that reasons, the Ford company and BMW, it is also developed the hydrogen engine, and for the 6 liter, and they use this engine for generating the power of 170 kilowatt, and engine torque is 340 Newton into meter. Hydrogen with the CNG. So that is with the CNG, that is improve the burning velocity of hydrogen. In laminar burning velocity is 2.9 meter per second, and methane is 0.38 meter per second is there. And improve the cycle by cycle variation caused by relative poor lean burning capability of natural gas engines. And fuel economy and thermal efficiency is also increased when we can use hydrogen with the CNG. So this thing, it is also adopted by the government of India. That is a 20% hydrogens with the 80% of CNG. And before that I'm talking about, let's say, injections methods. So various injection methods are there, but we already know. But in the case of hydrogens, that's a direct cylindrical injection method is very helpful, and that's injection with the pressure at the end of the compression stroke. And the problem of drop in power output and manifold reductions in injection can be completely eliminated. Backfire effect, that is also eliminated. Pre-ignition problem, it is also eliminated, and it is also increasing the power output engine to 20% more than that is a gasoline, when we can use the direct cylindrical injection with hydrogen fuel in the engine, in the SID. Now another things are there. This is one simple diagram, that is the hydrogen safety point of view. People are said about this thing. What about the hydrogen safety? You can see here that is a car. That is a two car is there. One is this one is a hydrogen based car, and the second one is gasoline based. So in both the place that leakages are there. You can see in after the 3 seconds, that is a flame, it is increasing, it is higher, that is a, and here it is small explosions are there. But after the 60 seconds, because of we know that is the diffusivity is more. That already we said that is a pitch, that is the diffusivity is less, and due to that reasons, it is start to reduce. That is a reduction of the impact of the flame. So this is a you can see in the third case after the 90 seconds. What about the hydrogen flame, and what about that is a gasoline? That is a problem. So that is a hydrogen flame has begun to subside, and the gasoline fire is intensified after that is a 90 or 100 seconds. Although the hydrogen was gone and the interior of the car was that is undamaged. And the gasoline car continued to burn from a long time and was totally it is damaged. So H2 is the safety, that is undeserved the reputations as a dangerous fuel. Okay, so it is safer fuel compared with the gasolines. Now these companies are there, that is a hydrogen energy in India. And already that I am said, our Prime Minister is also said about these things, that is a hydrogen mission. So actively some agencies are there, they are doing work. The Ministry of New and Renewable Energy, Ministry of Petroleum and Natural Gas, Department of Science and Technology, Department of Biotechnology, Department of Scientific and Industrial Research are there. With various applications that already we know. That is one application is the power generation, and second it is a transportation sector. These are the main two things are there. And another that we have developed fuel cell vehicle, and through that with the help of hydrogen as a fuel. This is a hard supply and demand already we have discussed in earlier cases, so not much more time is given in this case. Hydrogen's productions are here. That is a methane reforming is there, carbon capture, gasification is there, electrolysis are there. So these are the various process for the hydrogen productions are there. But somehow some people are told about that is what about the hydrogen storage is there. So that also I give after this slides, after this explanatory work, and I can say about that. Some videos are there. It is related to the hydrogen storage. So this is a number of vehicles are there that you can see in this PPT. So all vehicles, it is related to it is some renewable fuel that you can use. Some vehicles that you can use the HCNG blend people are using, and some vehicle it is related with the fuel cell. So these are the hydrogen fuel vehicles. You can see these are the hydrogen fuel vehicles are there. This is a hydrogen diesel SUV. This is also a CNG fuel vehicle. When I go to when I went to Faridabad IOCL, so people are doing the work with 20% hydrogen and 80% is CNG in various various vehicles, and that vehicles that we have perform hydrogens with CNG gases are there, and field trial that's up to the 30,000 kilometer for three-wheeler and 50,000 kilometer outer vehicles, and they have given some results. That results that I have put it here. So all results from the IOCL. That is the results are so Leland is there. That is what is the percentage of CO2 when you can use the 18% hydrogen CNG gas is there. So that is a CO is carbon monoxide. That is a reduction is there. Same thing, that is a total hydrocarbon is there. That is also reduction in the 18% is hydrogen CNG gas is there. 18% hydrogen, it is a compared with that is 100% CNG is there. But NOx it is higher. You can see there is NOx is increasing. So that is our problem is there in the, with the hydrogen fuel that you can use. So how to reduce the NOx? Because of NOx reduced when you have used the lean mixtures. Okay. So this in the case of Bajaj Auto, so same way, same results are there. That is a three-wheeler is here. It is 100% CNG. What about the carbon monoxide is 0.8 gram per kilometer is there. It's just you can see there is a near about 0.2, 0.1 near about that is a CO. That is a less. Similar way in the total hydrocarbon, that is also you can see it is also reduced when you can use the hydrogen, or that can say is a dual fuel that we can use the CNG plus hydrogen. Same way here, that one another change, that changes NOx. So NOx it is also reduced. So what is the things are there that I'm saying that is in this work that is in I think fuel by SCNG with the help of that is a petrol engine is there. So this thing it is a different in case of NOx generation in the case of this Bajaj Auto three-wheelers. Compare with this Mahindra Champion three-wheelers, you can see here that is NOx percentage is increasing with increasing the hydrogen percentage. But in the case of total hydrocarbons and CO carbon monoxide, it is decreasing. So this is also helpful to us when we have go for the when we have go to mix with the hydrogen with the CNC, and percentage of CO and percentage of hydrocarbon is reduced. Just we have concentrate on the NOx. That is also that we can solve this problem with that we can use the various catalyst, and that we can use in a mixture of hydrogen CNG fuel. Now the Mahindra Bolero passengers are here. You can also see that is a Mahindra Bolero carbon monoxide, total hydrocarbon percentage, and the NOx is also reduced. Some another results are there for the Tata Indica. Same way, that is carbon monoxide total hydrocarbon percentage is also reduced, but NOx is increasing. So this is some results. Another result, that is commercial vehicles. Same way, that is NOx is also reduced. So in some vehicle, that is NOx reduced, in some vehicle NOx. So that is basically the problem is related with the engine, and something that is related with the load conditions are there. So that's why some results are vary, but we can say that is a carbon monoxide and total hydrocarbon, it is reduced when we have used the hydrogen, 18% hydrogen in CNG compared with 100% CNG. Okay, now I'm talking about that fuel cell. The fuel cell, people are know about that. So the problem of the storage, the hydrogen storage problem is there. So through this video, you know about that hydrogen fuel cell. 1 minute. Is it audible?
Yes, sir, it is audible.
You go. Ronak sir, the audio is missing.
Yes, sir.
Yeah, the audio is not there. I'm not able to hear anything.
Okay.
No audio.
No audio.
No audio.
Okay, just I said what we explained. Okay.
Sir, if I can interrupt, when you open your tray, there is a box which says include system audio. So I think if you can click that, then it will be able to.
Okay. So here that is the last view. So presentations. Okay.
In the share tray option, sir. Share tray option.
Say tray in which?
On the
When
screen
you
itself,
share
right next to your mic.
Mic. First is video, second is mic, and third is shared tray.
share tray or share desktop, whatever it may be.
Sir, you'll have to go back to your Microsoft Teams screen. There, when you
Okay.
open the tray, open share tray, then you will get an option
Open
of
share.
no, not here, on your Microsoft Teams.
So
On your Microsoft Teams window.
okay.
Shared tray or shared desktop.
Here it is not given, I think.
No, not here, not in the PowerPoint.
So in
In the controls of Microsoft
yes,
Teams.
from where you can control your camera and your mic. Right next to it, there will be an open tray. An open tray, when you open, right, when you click there, you will get an option that includes system audio. Probably you'll have to minimize this presentation for that. And okay, anyway, sir, we can because it's almost 4:30, so we can proceed further.
okay. Just I have explained it. What is
Yes,
here.
sir. Yeah.
Okay. Okay. So main things are there. That is high pressure. when we that time are there, problems are there. That is in mass that was taken 200 bar, that is 8 kg. And 250 bar at that time
Ronak sir, probably the video is going on in the in the background, so it is interfering with your voice now. So I request you to please stop that video.
Okay, I mute the video. So now the high pressure hydrogen tanks, that is the type 4, the polymer liner, that is carbon structure is that. So working pressure is 200 bar, 350 bar and 700 bar is there. So what about the mass? The mass is that is a 17, 12 and 8.5 with the diameter of 220, 226 and 235. So here that we can use when we now the low pressure hydrogen tanks, that we can use the metal hydrate storage, that is refilling the 10 bar. So two types with intercooling or heating systems, or that without intercooling, that we can use this type of tanks. Now this energy for the compressions, that is a 1 kilojoule at 110 bar, that is our normal requirement is there. But in the case of here requirement of a minimum 120 joules are there, that is for hydrogen, that is 1 kilojoule at 700 bar. So when it is stored, so that is energy spent for the refilling stations. So what about the pressure that is required? Instead of 10 bar, there is more temperature it is required, so more pressure is required. Energy to store with the metal hydride, that you can see here, that is heat is dissipated and somewhere that is located like this type, and that we can use to store the our systems. Now this is the energy to store with the metal hydride. Again, that we can say that is a fast refilling systems that provide the minimum 120 joules of heat. Here there is 1 kilojoule at 2 bar in the hydride is there. So instead of 700 bar, we can use we can store that is a 2 bar with the hydride metal hydride that we can use as a material with the minimum that is a 120 joule of heat. So that is a working condition. You can see here that is a working pressure is in 10 bar is minus 30 degrees Celsius temperature. The outside temperature is minus 30 to 60 degrees temperature is there for the metal tank, metal hybrid tank. I'm talking about this metal hybrid tank is there. That is a casting of our intermetallic is there. That is a flow is dependent on hydride resorptions are there, performance and temperatures. So now another things are there, that is post projects are there. So where that we can put this methyl hydrate tanks, that is stored from the because of fuel cell that we can use here. So this is a efficiency point of view. The fuel cell 50% is there. 1 kilowatt electricity was 1 kilowatt of heat it is generated. Okay, so these are the tank that we can use in internal combustion engines of this this engine. You can see here, and some times are there, and due to that reasons I am not. Here that is a metal hydrate tank for internal combustion engine. People are doing work. Okay, so this is the one cycle is there. Now I'm talking about some another work. Okay, so this is a micro scale combustor with the hydrogen as fuel. Now in this case that we have used, that is a use 100% hydrogens. Here that we can use 100% hydrogens. Here we have prepared that is model of a Swiss full combustor with two types of cross sectional area is there. That is a variable cross sectional, and one another thing that is a non-variable cross-sectional of reactant and passage. So here you can see this one is a reactant passage and this is a product passage, and here this one is a combustion chamber. This combustion chamber size is that is 3 by 4 by 5 mm. Okay, so this is simple micro combustion chamber is that we have used the ultra-lean premix hydrogen air mixers in this case. This is the pre-mixtures. This is the layout of this particular experimental work is here, and how it is work that I'm saying that inlet through that is it is in reactant. It means the hydrogen air mixer. It is enter, and then after through this after the combustion process is completed in the central reaction zone. And then after it is produced, that is a product, that is a steam or vapor that we can say it is discharged from this area. So there is a product passage is there. So that this mm is 1.5 mm is there, and that is an inlet reactant passage. That size is only the 0.6 mm is there. So now this is the experimental setup for the particular micro gas combustion chambers. So this is the experimental work that I have done in University Surat. So now the this thing that I have seen here, it is some generated some hotspots are here because of we can use the 100% hydrogens are there. So this is one of the reasons when we have equivalent ratio is more than 5, then that's pre-ignition is also possible for the generating the hotspots. Now here that is a temperature distribution in central zone reactions and exit center reaction zone at a constant cross-sectional area reactant passages are there. So the temperature distributions at central reaction zone, that is an exit of the reaction zone, somewhere is a constant area reactant. It means that I'm saying that is this one that is a reactant passage, and this is reactant, and this is a product passage. Both the passage that is constant, cross-sectional area is remain constant. So at that time the temperature it is exit of reactant zone is more than that is a central reaction zone temperatures. So what happened that we already know that is a heat release is more at exit of reaction zone. So this means that the flame front is extended in the product passage, and due to that reason this hotspot is generated that already we have seen in these earlier slides. So that what happened that what can we do that suggests that residence time is increasing in the central reaction zone. It is less, so that we can try to increase it. So residence time can be increased by increasing the cross-sectional area of the central reaction zone or by decreasing the velocity of reactant. So two solutions are there. So in the case of temperature distribution in central reaction zone and exit of central reaction zone for variable cross-sectional that we have taken. So at that time that we can achieve that diffusing the passage from 0.6 mm to inlet 1.5 mm at central zone reactions. So variation of temperature for variable area reactant passage that you can see in this figure. So heat release due to the combustion is confirmed at central reaction zone as a maximum temperature is obtained at central reaction zone compared with the exit of central reaction zone. So now these are the also the another experimental work results are there. So now I'm talking about here that one important part is there, that is NOx formation start. So here you can see that is a zero emissions because of equivalence ratio is very low. That's why I'm saying there's a lean mixture conditions are there. So NOx reductions are there, and then after it is increasing. So this thing is very important when we have used the hydrogen as a fuel. Main things are there. That's why what is the conclusion of this experimental work? We have suggested that the present chamber be operated at low equivalent ratio of 0.4 or below, and is generated of the maximum temperature near the exit of central reaction zone, and is advocate for the increase of residential time in central reaction zones. So this is also you can say that is the results is 0.43. That what about the reactant temperature and reaction zone temperature? So that is higher than that is a auto-ignition temperature of the. You can also see here this things that is NOx emissions. It is also increasing rapidly after the 0.4 to 0.43. So, another one, before I complete my presentations, one video, it is related to uh, the difference or comparisons between the battery vehicles and hydrogen fuel cell. Okay, so I think it is possible, then I will try my best. So is it what? Because Yeah. Just wait, I will try to her voice.
Ronak sir.
Yeah.
Yeah, doesn't matter, sir. So you can, what you can do is you can send the video. We will put this video in the group, right?
Okay.
And the participants can watch the video at their convenience, right, sir?
Okay.
Because I think there is some issue with the sound,
Okay.
right? We can see the video, but we cannot hear hear any sound, right?
Okay. So now, then okay, that my conclusion slide. So hydrogen indeed is the ultimate green and sustainable fuel for futures. But many important things are that how we quickly we approach the future world, large depending upon the collective efforts by the stakeholders that already we have discussed in earlier. So development of the cost competitive hydrogen production technology based on renewable methods. We also develop for the cost effective technology for onboard storage of adequate quantity of hydrogens. Development of infrastructure of production, transportation, storage and supply of hydrogens. These are the requirement, that is introduction of hydrogen fuel vehicle in large number based on either IC engine or fuel cell technology. Ultimately achieve the reduction in cost of fuel cell cost with increasing the production volume and improvement in useful life. So development of codes and standards for hydrogen based system as well as hydrogen as a fuel. Hydrogen is to declare as an automatic fuel in India. And last but not least, creating awareness about the hydrogen. And then we have said about these things, that is hydrogen as an alternative fuel for the automotive industry. Thank you. Thank you. Is there any question?
Yes, sir. Thank you very much, sir. There are a few questions. I will take one by one. Mr. Mehul Kumar Padia asked, what about the safety when we use hydrogen as a fuel in automobiles?
That already I have explained in one PPT. That is a simple, diffusivity is high, and due to that reasons, it is dispersed in atmosphere very rapidly. Right. Due to that reasons, it is safer than that is a gasoline on CNG.
Okay, sir. Thank you. Our college BBIT head, electrical engineering department head, Professor Ashok Parmar sir is asking, is this the best time to buy e-car with hydrogen fuel cell in the Indian context?
In e-vehicle nowadays, that is the electric vehicle is viable because of there is no more infrastructure related to hydrogen fuel cell, and number of fuel charging station is not available compared with electrical vehicle charging stations. So at today's Indian present scenario point of view, electrical vehicle is suitable compared with the fuel cell because cost is also high.
Okay, thank you, sir. And Dr. Shiva Murugan is asking, can you share some information about installing electric charging stations in India?
I also don't know, but after some day, I also find out because of a number of companies, those directly, I think Cell, that you can say Cell is there, another IOCL, those company, they have already prepared their own charging stations. Okay, Reliance is also they prepared the for own charging stations. So every petroleum company, IOCL, HP, Shell, this all company they will they already planned and prepared their charging stations.
Okay, sir. Professor Varya Rajendra Kumar is asking, how much compression ratio is achievable currently in engines having hydrogen fuel?
Compression ratio that it is less because of it is near. I'm talking about the air fuel ratio is there, so it is 34.1 is there. But you can use which type of engine that you can use in a SI engine is there. So then it is near about that is a 15 to 15:1 ratio is there.
Okay, his next question is, does high diffusivity 0.63 square cm per second create any problem in storage of hydrogen?
So that's why I'm saying that is a problem. It is a material. That's why I'm saying that is a main issue. That is in a hydrogen point of view, it is a storage problem, and that's why the tank that we can use the tank. The volume of the tank it is also the larger. I think now the 5 times more volume tank it is required when you can use the same fuel that you can use instead of hydrogen or gasoline. So that's why the second things are there. That is a pressure. The pressure is also required, or you can use the liquid or cryogenic fuel, hydrogen that you can use. So this is the problem. This is the issue in the case of hydrogen storage, and this is a research work.
Okay. Mr. Anant Malia has asked two questions. His first question is, sir, isn't NOx percentage a function of peak cylinder temperature?
Cylinder temperature
NOx.
is not, NOx is there. NOx, it is directly related to the reactant temperature, and then when it is combustion process is there, if it is a temperature is higher, then, but obviously it is NOx, it is increasing. If it is equivalent, that's why I'm saying it is equivalence ratio is lower is there, lean is there. So at that time, that is main thing is that it's oxygens. The oxygen is 100% combustion with hydrogen fuel, then it is possible there is no possibility of the NOx, but the possibility is NOx when we have used the lean mixtures. So at that time, that is oxygen is directly contact with the nitrogen. So that is NOx is generated. So this thing it is possible with the this NOx preparation or NOx making or that we can say it is a chemical reaction process with the high temperature, not with low temperature. So if high temperature is there, there is NOx is more.
Right. And Mr. Anant Malia's second question is, how is NOx reduced in HCNG engines? Doesn't hydrogen burn hotter than just CNG?
Sir, please repeat the question.
He's asking, how is NOx is reduced in HCNG engine? Doesn't hydrogen burn hotter than CNG?
No. That this is the way that is the mixing is there. That is the most important things are there. That is the mixtures. Okay. So the NOx, when it is increasing, when the hydrogen it is contained with that. So hydrogens are there. So hydrogen plus oxygen. Then another that is a CN, that is a carbon, that is a methane, or all the components are inside. So at that time, the main important things are there. It is a combustion process are done. So at the end, that is NOx, it is increasing because of that formula is there with CNG and plus hydrogens. So no any other way, just only the chemical reactions are there, and due to that reasons at the product, because the reactant is there and product are there, the product is always, it is a part of the after the combustion of the reactant. So that's why it is NOx, it is higher in the case of hydrogen mixing is there.
Yeah, right, right. And one more question from Professor Variya Rajendra Kumar is, hydrogen is a clean fuel. Why is carbon monoxide and why carbon monoxide generated by combustion of hydrogen? He is asking that hydrogen plus oxygen is a water, that is H2O. Then why CO and THC are generated?
It is not generated. CO and CO2 is not generated, only the NOx is generated. Okay, no CO and CO2, it is generated. If you are using the dual fuel, if you are using the CNG, the hydrogen, so then it is possible to generate that CO and CO2.
Right. So thank you very much for clearing the doubts.
Thank you, sir.
In detail, sir. And I take this opportunity on behalf of BBIT College and on behalf of BBIT FDB team. I convey my deep sense of gratitude towards Ronak Shah. He has given a very good information about hydrogen fuel. He has started his presentation with energy scenario and challenges. Each of these slide was loaded with so many valuable information, sir. You had touched many areas in one presentation. You have talked about green energy. You have talked about hydrogen as a clean energy. You have talked hydrogen fuel, hydrogen safety, and so many areas you have touched, sir. We are really thankful to you for such a valuable, informative session, sir. Thank you very much, sir.
Thank you, Gundari sir, and thank you all Mechanical Engineering Department of BBIT. Especially thanks to Dr. Adi Patel sir and Makwana sir. Thank you everyone.
Thank you, sir. Thank you.